Hi, welcome to a new video. In the last video, we have seen how you can create VMs, means EC2 and VPC in AWS. So we have set up EC2, some route table rules, some security groups, some subnets, and also we have created three VMs, which you can find over here, right? But these are the three VMs which we have created in the last video. If you have not seen that first video, I will give you a link in the description. Okay, you can check it. So in this video, what we can do is that we will create the cluster, or we will set up the cluster with these two machine, worker and master. And as you know, we are accessing this jump server only from our system, from our local terminal, and from this machine we are accessing these two machine one by one. I have started all these machines. That's why it got each one of them as a public IP. Okay. So in this video, we will see how you can install Kubeadm and the Kubernetes related components like Kubeadm, Kubectl, Kubelet, and some container runtime interface and set up a cluster. Okay, so let's just go into that. So let's just connect to the terminal, and you need to go into this folder where you have saved your private key. In the last video, we have created a private key to connect this jump server, right? So you need to go into that folder first. I will create three terminal window. I will tell you why. Let's first go into this folder, then just connect to the jump server. Okay, from each one of them. If you want to know why I have running this command, SSH is the protocol, I is for the private key, Ubuntu is the username, and this is the public IP, and -p means port 22, which is we are connecting through SSH, right? So, oops. So we have three terminal window, each one of them connected to the jump server. Right now, let me just rename this one. Jump master. So from this terminal window, we will connect to the master VM, and this one will be your worker. Okay, just color this one. So this one for easy understanding where I am right now. So, yeah. So as you know, we have a key file from here. Let me just go to this master. We have a key folder which we have created, and inside that we have two cell file. So and if we run this cell file, it will automatically connect to this master node, right? So previously we are in the jump server, we have run this cell file, it's connected to the 1.10, which is the master. So 1.10 is the master, 1.20 is the worker, 1.30 is the jump server. So let me just quickly do that in the worker node also. So worker, and we are connected to 1.20. Now, now before installing other components, you need to just update your system. If you have inducted, if you have started a new instance, you just need to do sudo apt update. Oops. I have already updated this machine, so it will not update that much. And you also need to do sudo apt upgrade. Okay. Yeah. So I will do quickly for the second machine. I will fast forward this section. Okay. Yeah. So now the VM is updated. So you just hit enter, whatever comes in front of you. Okay. No problem at all. Now make sure you don't have any pre-installed container runtime interface. So if you are installing Kubernetes, all the application or the pods, which you call pods, everything runs on a container runtime interface. You have heard about Docker, Containerd, CR, Cryo, all are a container runtime interface. So if you have installed previously, you can just uninstall, which I have done for this machine. So I will just remove that one. Yes, let me just remove this machine from this machine. I'll install from the start, but for this machine there is no container runtime interface installed. Okay. So, nothing is installed. Yeah, so this one is all in this machine also. It is done. Just check. Nothing is there. Okay. Now fine. Now in the Kubernetes documentation or in the website, the clear documentation provided how you can install before installing the little components of Kubernetes like the Kubeadm, Kubectl or Kubelet. At first, you need to configure your container runtime interface in such a way so that it can allow all the other components to work properly. Correct. So I will give this. Ping this link in the description. How you can install container runtime interface. I will use container D. You can use Docker engine also. No problem at all. But before that, you need to just enable this little thing. So forwarding IPv4 and IP tables bridge traffic. So whenever container runs on your system, it uses this bridge in IP tables to transfer the traffic from one container to another container. So you can find these details in the Linux documentation and in networking page. So, but you just copy this thing and go to your master node. So remember one thing: whatever commands I will run for both of them, like master and worker. Each and every component will be installed on master and worker both. When you are starting your cluster, you need to decide which one will be your master. It doesn't matter if I have named it here master. I can create this worker as a master. Okay. Whenever you are creating your cluster, setting up your cluster, at that time you need to specify. So just run this command and go to the documentation again and just check if not this one. So just go to this one. So uh, we have enabled this little things and we have checked if these components are there or not. It's not there, so we just want to enable those things. Okay. I'll go to this one and check system and apply these settings. I don't know why my copy and pasting thing is not working, but you can ignore this one. You can just copy this thing, check, and you can see there is IPv4 settings. Whichever you have applied, it's enabled. So yeah, there is also one command for that one. You can check verify. Like if whatever you have applied, net bridge, NF IP tables, and IP port, IP forward. This you have mentioned one means this is enabled. Okay, so you can go to this one and you can see everything is enabled. One bridge is enabled and other things are not there. Okay, so that's all, and also verify that these things are there. So you will just copy this command and you can see everything is 111. The bridge is one, the IP forward is one, and IP tables, whichever you have set, it's everything is working fine. Now, C group drivers. So C group driver is like if you heard about systemd, how your application runs, it runs as a group of service. Like systemd is a group under this couple of resources are running. So I'm not going into details how this is working. So what you can do is that you can install container D. Okay, container D as a CRI, container runtime interface. So you can find the container D in the our package manager itself. So you can just sudo apt search. So you can find the container D over here. So this is the container runtime interface. So the command we have run before, I will run the same thing for the worker once this whole setup is done. Okay. So now a CRI version support, which CRI you can use container D, cryo, different components out there. So At first, let's install the container-d. So sudo container-d. So one unit is installed, so it's installed. Now after installing, you need to reboot the system. Okay. So systemctl reboot. Okay. So we have disconnected from this master node. We are come back to this jump server. I'll fast forward this section. It will take around 10-20 seconds or 30 seconds maybe to again start up the whole server. So wait for a couple of minutes. Now we have connected to this our master node again after rebooting. Now you can, if you check, after installing container-d, our container is running. Yeah, it's running perfectly fine. Okay. So right now we need to do some modification. So the container-d, we need to add, or we need to run our container runtime interface as a systemd C group, so that it can share the resources. It can run as a group. Okay. So you can see configured in systemd C group, and there's a lot of options you can see in the documentation. If you can go through it, it's a long list. But main thing is that systemd C group driver, blah blah blah, container runtime, and here. So once if you install Docker, you can see there will be a file in the etc. There will be a container D folder will be there. Okay, which is not here by the way right now. Which is not here. But if you install Docker, a container D folder will automatically created. Inside that, there will be a config.tuml. Now you ask, what is this? So that is the main configuration file of a CRI, container runtime interface. It includes all the default configuration of a container runtime interface to run it properly. So it's not present right now. So what I can do is that we can create a new one over here. So go dir container D. Okay. Now if you take some one container D folder is there. Now we need to run this thing. We need to create a file called sudo. So I am using root as a sudo. Okay. Usage. No, I have pasted the wrong thing. Let me just remove that thing first. Just go to this, and here I need to create this file. Okay. Right now this config.tuml file is there. Now what I need to do, I need to now if you check the file, there is nothing in this file. So you ask like, where can I get the configuration, default configuration? So that for that there is a command which I will show you. Nothing is there. Like, sorry, not echo. You have to do the cat. Nothing is there. For that, if you go down, if you see uh, this command, like if you install container-d from a package manager in Ubuntu or a Debian, whatever. What I faced previously is that I have set up a couple of cluster, and my master node got down continuously for it. It keeps on for 2 to 3 minutes, then it keeps getting down. The API server, the control plane keeps getting down. Further, you need to import the default configuration of a CRI. The CRI is not properly configured. That's why your whole pods, your whole master node goes down. Okay. For that, you can run this command under the default. Make sure you run this one. Close this one. Config default. If you just do this config default, you will see the whole default configuration of the CRI. So this is the default configuration of this container D or the container runtime interface. So you can just copy this thing because it's showing some permission error. So yeah, so you can just open this config.tml and just I control V paste escape w tar. Now you need to restart the container D. Okay, after giving this default configuration, you need to restart the container D, and or better you can restart the server also, no problem. Okay, or better you can restart. So we have connected to the cluster, not cluster, the server. So let me just check the status of that container D, which is the container D. Okay, I missed the status part. Yeah, it's running perfectly fine, and our default configuration is also there, right? Now, our container is configured in such a way, and the default configuration imported. Now, if you see here, we need to add this C group, systemd C group, true, so that it can use the systemd C group, not other C group. So C group means that it will systemd has a group. In this group, there are a couple of processes running as a group, so that it can request some different resource, memory, hardware, like CPU memory from the kernel level. Okay, so you can check in the Google for more about systemd. So just go to that path, container D, sudo vi your config.tml, and if you scroll down you will find, scroll up, so I'm already down, so there is some systemd C group. So if you see this IO container D grpc v1 cri container D runtimes run C options, so and that is what it means, run C option. So I will just give you an overview idea how what is this. So it basically means that just make a little upload. So this run C actually is the main agent or main package which runs your container. Container D uses runs container D is a over a high level view of your container runtime. Runs is the low level view. It actually uses a resource from the kernel level to run your container more specifically. Okay, so we want to run this thing as a systemd. So just make it as a true, and you need to again restart the not server, only the container D. Okay, so you need to just 2 3 times or 4 5 times you need to restart your server or the container D, because this is the main part where your pods will be running. If you misconfigure your container D or CRI thing, your pod will not run, not even the application. That will be very disastrous. Okay, so let me just check the status once. Status is running. Okay, now this container D installation part is done. I'm telling, if you have downloaded the Docker or container D and did not set this default configuration, make sure you do that. Otherwise, you set up the cluster and after 3 4 minutes 5 minutes the master node will be goes down again and again. It will be crashed because of this because the default configuration which you installed from this package manager, it's not compatible for cluster operations. Okay, we just need to, if this folder is created for you, it's okay. If the file is there, it's okay. If you install Docker, it will be there. Otherwise, you need to create a folder and create a file, and you do import this default configuration and restart the thing, whole thing. Okay. Now, system container D. That's all. We're adding the sandbox image. This is not required. This is for the cryo. We are not using cryo. We are only using the container D. That's all for this CRI. Now let's move on to the main part of installing Kubeadm. Okay. Now make sure I will do the same thing for the worker also. Now before you do, it will ask you to check the connectivity of 6443, something like that, which is already there. In the last video we have enabled some security groups to talk, to allow all the ports and all the traffics between the same subnet. You can check the first video. Kubeadm is the main management software to create a cluster, manage a cluster, delete a cluster, and for admin to create a cluster more specifically. Kubectl is your agent, or you can say just like we use gcloud auth or azcli. It's a CLI to communicate with the cluster. It's a CLI from where you can access a cluster. It's not used to create a cluster, it's used to connect and manage a cluster. And kubelet is the agent who listen for different configuration changes or different instruction in each and every node, so that it can run pods, application, and different things. So you can check in the documentation for more details. Okay, so now just copy the whole thing. This part we have done already, so or you can copy it, no problem, but we can install this part uh, for now. So, not this one. My copy control C is pretty bad. Okay, so ignore that one. Things, a couple of things are there, a couple of things are not there, so it's installed. Now this public signing key for Kubernetes, this thing, it's there, it's done. Now Kubernetes repository we need to add so that we can download different things from there. And now we just need to run this command. So till then it's installed, I will show you. So we are updating what we have added on repository. We have added a public GM key, public signing key. So we are updating the repository. We are installing Kubelet, Kubeadm, Kubectl from this repository, and we are marking as a hold, means it will not update automatically. Okay, until or unless we manually update it, so that it doesn't accidentally update to different versions. So it's updated and marking as a hold. So now let's let's just go to the second part. Restart the whole server once more time. Our master node has been connected at 1.10 IP. Now if you check the status of, let's check the status from the beginning. So at first we will check the status of the container D. It's running. Let's check if kubectl is installed. It's installed. Let's check what is the status of kubelet. Yeah, it's working fine. Means it's running. It's not started yet because when we will initiate the Kubernetes cluster setup, then it will start. Now, let's right now we are in masternode. We have downloaded the components to create cluster. We have not actually created a Kubernetes cluster right now. To do so, we need to run a couple of commands. We go to the Kubeadm. So here now you can see there is the option use Kubeadm to create a cluster. Correct. So you have to go down here. So there is a command called Kubeadm init. If you specify init, it will initiate a Kubernetes master nodes more specifically. So if you are in master node, suppose you have 3 or 4 VMs, you have done all the previous steps which I have done for the last couple of minutes. In which node you want to do as a master node, you need to run the kubeadm init on that node itself. Okay, if you run in a different node, that will be the master node. So if I suppose if I done all the previous steps on this node, and if I run kube init on here, so this will be the master node. The master named node will not be the master nodes. Okay, the init means you are inserting a control plane or the master node. Now there are a couple of things you need to mention, which I have a sheet over here. I can show you that one. uh, yeah, so this is the thing I would also mention. So if you are initiating, so let me just tell what is this command all about. So you need to use sudo for running as a root. Kubeadm init, you are initiating a control plane server. API server advertise address like where your master node will be listening. Here you need to mention the master node IP. So for our case, it will be 172.0.1.10. 172.0.1.10. This will be your master node. You can go to your EC2 management console and check. This is your master node, right? The master. So this will be your master. This will be the port where your master node will listen. Master node will listen. So 6443. Pod CID range where your pod will be advertised. You can give any IP ranges. I have given 10, 100, 0.0/16. Service CID where your service will be listening. You can give 10, 195 or 172 series, whatever you prefer. Node name. Suppose I am giving here master, simple master. So if I run this command, let's see what actually happened. So if I run this command on this master node, on this node, so here a Kubernetes control plane will pop up on this IP. It will be listening on this port. Whatever pod you will create, it will be created on this IP ranges, and whatever service you will create, the service IP will be inside this range, and node name will be master. Okay, just this thing. Yeah, it will check some prefab checks before initiating your cluster. Okay, it will automatically go through. If there is any error comes, you will see over here. So it is downloading some container images to run, just like your cube system, cube something something like that. So different things are coming up over here. Yeah. Now it is saying to start using your cluster, you need to run the following as a regular user. So make sure you are in this home your user directory. Just copy this thing and paste it over here and run it. So what it does actually, you are in the master node. It will configure your kubectl agent in such a way so that you can access the cluster as a cluster admin. So let me just check. So kubectl get ns. You will see these are the, so our cluster is set up. Our one master node cluster is set up. There is no worker node right now. I will set up this one after explaining this one. So kubectl get nodes. Yeah, this is not ready because the reason I will tell later. So right now our master node is there, and also there is no such, only one node is there, which is control plane. Now you see there is another option. Then you can join any number of worker nodes by running the following command. So this command you need to run. Then you can, so after, so previously we have done the installation of the container D. We have set up some IP tables rules, some default. We have changed some default configuration of container D. We have installed Kubelet, Kubectl, Kubeadm. We have inserted the cluster, and we will do the same thing for the worker node. Master node have only the ability to expose the token so that worker node can use this token to join this cluster. Okay, let's see what are the pods right now is running in the default like cube system. You see, right now we have this thing running over here. Okay, like this cube API server, cube controller, cube proxy, cube scheduler, master, something. So let's just do the same thing for the, without initiating a cluster. So we will install the required configuration, required software in the worker node, and we will create a token from this master node, and we'll go to the worker node and run it so that it can join to the cluster. Okay, now I will fast forward this section. Let's just So now here I have done the previous commands. I have installed container D. I have configured the default configuration of the container D. I have enabled the systemd group in the container D config.tuml file. I have started installing. I have also added the ibtables rules, which is already present in this documentation. Also installed right now the kubectl, Kubeadm, and Kubelet. Okay. Now everything is okay. Let me just reboot the server once more time. So right now this master node have only one node is running for the last 11 minutes. So if you are not configuring that CRI part properly, your control panel will go down each and every time. You will not able to see this detail. So it will show some connection timeout error, not able to connect, refuse connection 6443, something like that. It will show. You can see what are the total pods currently running in your cluster. Get pods. These are the all pods running currently. Code DNS is not running. We'll configure that one also. Just connect to the worker node once. Yep. Right now, let's check everything is perfectly working fine or not here. We have not configured this worker node in the master node. Okay. Yeah, just checking. It's running. Let me check the kubectl. It is also working fine. Let me check the kubelet. It is also loaded. No problem. Now to join this master node, at first master node needs to send a token so that that token can be used by this worker node to join. For that, you will find, just type Kubeadm help. So what you want to do, we want to create a token. So Kubeadm create -fl help. If you do, sorry, token, we want to create a token. So we need to go to this token part, and you want to create a token. Yes, we want to create a token. Suppose you go to help again. Now Kubeadm token create and print join command. So it will print a join command. Okay. So it will show this command. Okay. Now here is this. So the both thing are same. If you add this node name at the end, so it will join this worker node with this name. Okay. So you just copy this whole thing. Go to your worker node. Clear the whole screen. Paste it. Node. The attribute you can find it here over here. It will show something over here. So it will be on. It will be in join help. Join there will be some, yeah, node name is a parameter, hyphen node hyphen name. So it's a parameter, node name, suppose worker. I need to run it root, then sudo. If you don't have sudo, you can just log into the root and perform all this activity. So it is starting the kubelet. Yeah, it's joined. Now you say, how can I run the kubectl from this worker node? Can I check? The answer is no. You have to, every time you need to run the kubectl from the master node. So go to the master node, clear the screen, run this kubectl get nodes. You'll see there is another node is added, worker node. Okay, cool, fine. Now I'm going to say why it's showing not ready. Now we have what we have done. We have installed container runtime. We have installed Kubernetes components. That's it. Kubernetes has created. Now, how Kubernetes will communicate, that is depending on another most important thing, which is called CNI, Container Networking Interface. So Kubernetes is like different hosts will be there, multiple nodes will be there. They will communicate to each other, right? They are pods, they're containers. How this thing works, CNI or container runtime, container networking interface takes care of that part. We need to install a container networking interface like Calico or your Flannel or whatever. So we'll install Calico over here to make this setup ready. Otherwise, you will see the core DNS will be on pending state, as I saw a few minutes back. Where is this command? Yeah, this coordinate is pending one because there is no such container runtime networking interface ready. So even if you schedule the pod, they'll not able to communicate because of that issue, because there is no networking is happening. You have two nodes, they are joined in the Kubernetes cluster, but to interpod communication, service communication, cluster IP, node pod IP, they all need the CNI part. Okay, to do that, go to the Google, search Calico. You'll find the documentation over here. So you can download. I will download the manifest because I have tried this operator, but I don't know why it's not working properly. So I just download this manifest file. So this is the manifest. Just go to your master node. So the command will be run from the master node. Okay. Right now we are, every time you run the command, it will be run through the master node. Now in the next video, I will show you how you no need to use the master node. You can log into the jump server, and from the jump server you can access your cluster. That we will do in the next video, not in this video. But for now, let's see, we are in. So let's make a folder. No need to make a folder, just paste this thing. So it will download this manifest file, calico.yml. You don't need to do anything, you just need to kubectl apply -f calico. Just run that one, no need to do anything. It will create a lot of resources, lot of CRDs, custom resource definition, which is you can create. So now it will create. Now let's just check what are the namespace currently. Yeah, sorry, I need to give the get. Nothing is there, right? What is, nothing is created, right? But if you check get pods and cube system, you'll see coordinates is ready right now because of this Calico CNI. Right now every pod is running because of this CNI. Now let's check the status of the nodes. Yeah, it's ready. So that's it. Your two node Kubernetes cluster is ready. One is master, one is worker, and that's it. That's it for now. So make sure, a couple of points I would mention before ending this video. Make sure you have a proper security groups configured. Suppose your master node is in different subnet, your worker node is in different subnet. Make sure both have proper security groups, like they can allow all the traffic, all the ports internally. And if you have facing the cluster shutdown issue, which I faced mostly, just make sure you have CRI configured properly. Make sure after applying the default configuration of the container D, you just restart the server or container D, any one of them. Okay, after installing the kubelet also you can restart. I restart each and every time after installing, so you can do that also, not a problem. But that's it. Your two node Kubernetes cluster is ready. One is master, one is worker. Every pod is running fine. In the next video, what you can do, right now we are accessing the cluster from the master node. We will go to this jump server. We will create a user in the master node and give proper permission and create some tokens so that we can use that user from the jump server to access the cluster instead of log into the master node. In this way, you could have a little bit control over who are accessing your master node. Suppose you don't want to give anyone your master node or worker node permission, master or worker node sitting in a different zone, something like that. So you could give your user or your friend or anyone the jump server access. They can log in with this credential, whatever installed in this server, not in the master node. So that thing we will configure in the later part, in the next video. Okay, for now I think that's all. You can check as many times as you want. That thing will be showing over same. So it's ready. 20 minutes, 5 minutes. Yeah, this is the version 1.28. So that's all for this video. We'll catch up on the next video where we can configure user permissions and we'll access the cluster from the jump server. Thanks for watching. If you have anything to address, you can comment or you can reach out to me in any social media. Okay, thanks for watching. Bye.